Hello, class of fifth graders. Thanks for joining me for our first lesson of Module 9. We're going to continue multiplying fractions. And in our first lesson, we added on to what we've already learned, and we threw in some multiplying of mixed numbers, if you remember from class. So I'm going to share my screen with you and show you. There we go. There it is. All right. Here is our lesson 1 for module 9. We're exploring area and mixed numbers. And you can see it says, a little closer and hope it doesn't fall on me. Okay, maybe it'll stay. Marisol hangs a painting on the wall. What is the area of the painting? Use the rectangle to draw an area model, then solve the problem. So we talked about in class, and it seemed like class went really fast today, but we talked about if I have 1 1/3 foot and 2 1/4 foot, what that really says is that is 1 1/3. So when I hear that and, that's like an invisible plus sign right there. So I can split this model into 1 whole and 1/3, like that. When I hear 2 1/4, I can break this apart going the other way. I have 2 1/4. So then we're going to use this model as we know for area. I'm going to multiply each rectangle where those numbers meet. 2 times 1 gives me a whole 2. 2 times 1/3 is going to give me 2/3. Oh no. Yes, 2/3. Sorry, for a second I thought I did that wrong. 2 times 1/3 gives me 2/3. 1 times 1/4 gives me 1/4. And 1/3 times 1/4 gives me 1/12. Now that I have that, I can look at each of those parts in that model to find the area. I would have 2 plus 2/3 plus 1/4 plus 1/12. Now I have to go back to our lessons on adding fractions. And of course, I'm going to need to adjust because I have thirds and fourths and 12ths. And when I'm adding, I need that common denominator. So when I look at those, they all share the factor of 12. So I'm going to adjust right here. Instead of 2/3, that would be how many 12ths? 3 times 4, 2 times 4, 8 12ths. Here again, I'm going to adjust to 12ths. 4 times 3, 1 times 3. So now I have 2 plus 8 12ths plus 3 12ths plus 1/12. So that's going to give me 2 and 8, 11, 12 12ths, which, as we know, is going to give us a whole 3. And we're talking about area, so I'm going to label that as 3 square feet. So there's a refresher for finding the area of a multiplication problem with fractions and how we can draw that model. Let's do it again. 4 2/3 times 1 1/2. So thinking about that, and 4 and plus 2/3, 1 and, or 1 plus 1/2. There it is. 1 times 4 is 4. 1 times 2/3 is 2/3. 4 times 1/2 is 4 halves. I'm going to adjust that right away here. 4 halves is really a whole 2, and I'm going to circle it so I remember that's what I want to use. 2/3 times 1/2, 2/6. So now I have 4 plus 2 plus 2/3 plus 2/6. Again, right here, I'm going to adjust 3 and 6 for my denominators if I'm adding. So I'm going to adjust and make this into 6. 2/3 would be 4/6. So I have 4 plus 2 is 6. 4/6 plus 2/6 is 6/6, which gives us a whole 7. Ooh, these are working out so nicely. 2 1/2 times 3 1/2. So 2 1/2 by 3 1/2. 3 times 2 is 6. 3 times 1/2 is 3/2, which is 1 1/2 I'm going to use. 2 times 1/2 is 2/2, which is 1. 1/2 times 1/2 is 1/4. So I have 6 plus 1 1/2 plus 1 plus 1/4. I'm going to adjust this 1 1/2 to match the fourths. That would be 2/4. 6 plus 1 is 7. 2/4 plus 1/4 is 3/4. All right. There is a math on the spot video. If you would like to go using your Clever account, I will have this assigned in our HMH math on that link into math, and you can watch that math on the spot and see how that goes for you. Let's look at the test prep. Which product could be represented by the shaded part of the area model? So now we already have the shaded model. What I'm going to need to do is determine, as we worked in class, we knew that multiplying our numerators gave us our total for the area, right? The total number of cubes or blocks. So if I look, I have 1, 2, 3, 4, 5, 6, 7. I'm going to mark that up here just for me to remember. And I have 1, 2, 3, 4, 5. So the reason I'm thinking about those numerators is because I would have these improper or these mixed numbers change to improper fractions. And then I should have a fraction that has a numerator of a 7 and a numerator of a 5. So let's see what happens. 2 times 2 is 4 plus 1 is 5. 3 times 2 is 6 plus 1 is 7. So I'm going to put a little star by that. That one seems like it could work, but I'm going to check again on these other ones. 4 times 1 is 4 plus 1 is 5. 4 times 2 is 6 plus 1 is 7. Uh-oh. Let's think about this because now we have thirds and fourths. We've got some different things going on. Let's see what happens with all of these. 3 times 1 is 3 plus 2 is 5. 3 times 3 is 6 plus 1 is 7. Okay, good thing I didn't just go with that first one, right? 2 times 2 is 4 plus 1 is 5. 4 times 1 is 4 plus 3 is 7. So they all have the correct numerators. How am I going to determine this? So we have 7 by 5. We have a total of 35 boxes then that are filled in. How can we determine which one of those could be represented? Oh, goodness, sorry. I've got to adjust the knee, friends. All right, so let's look at this a little bit more. Oh. I'm trying to determine which one of these would give me the best representation. 1 2/3, 2 1/3, 2 1/2, 2 1/3, 1 1/4, 2 1/4, 2 1/2, 1 3/4. We're kind of working backwards from our lessons because we didn't do this in the actual lessons. So let's take a look. 2 1/2, 2 1/3. Am I going to be able to, in class we did, so if I have 2 1/2, if each of these is a half, I would need 1, 2 1/2. Could I do 2 1/3 with that if they are the same size squares? Our cubes are the same size, so we can't use that. Different denominators. I'm going to go ahead and eliminate letter D as well. Different denominators. So what if I'm doing fourths? 1 1/4, that would be 5/4. Can I do 1 2 3 4 1 2 3? No. 1 2 3 4 1. Do I have enough? Do I have enough blocks in this area to do that? What if I have 5/3? So that tells me 1, 2, 1, 2, 3, 4, 5, and 7/3. 1, 2, 3, 4, 5, 6, 7. So if I had 1 and 2/3, if each of these is a third, then we know that we need 3 of them to equal a 1, right? 1, 2, 3, there's 1, and we have 2/3 left. Here, we need 3 of them to make 1. 1, 2, 3, 1, 2, 3, and then we have 1/3 left. So this is becoming, I'm going to double star that. That's becoming my favorite. 1 and 1/4. That means I need what? I need 4 blocks to make 1 whole, and then I'm going to need 1 more left over. So let's see. 1, 2, 3, 4 blocks and 1 left over. Uh-oh. Here, I'm going to need 1, 2, 3, 4, 1, 2, 3, 4, and 1 left over. So this one doesn't work either. That's going to leave me with my double starred letter C. Woo! That made my brain work backwards a little bit. All right. But what I'm looking at is in class, we talked about if they are the same size cubes, we have to have the same denominator. That was a good place to start. And then we're thinking about how many of each do we need, and does that work for the blocks we have? Okay, we can go over that again in class and do some more practicing on that one if we need to. A rectangular shaped mural has a length of 1 2/3 feet and a width of 1 1/4 feet. Which is the area of the mural? 1 2/3 by 1 1/4. Here's where we need to either draw the model or use the Columbia C. Let's do the Columbia C on this one. 3 times 1 plus 2, 5/3, times 4 times 1 plus 1, 5/4. 25/12. I want to change that back to a mixed number. 12 goes into 25 2 whole times with 1 left over. 2 1/12 square feet, letter C. Select all that equal 3 3/4. We've got a little work to do. So I've got, let's see, 5/2 times 3/2 equals 15/4, which equals 3 3/4. Ooh, first one, winner, winner. 1 1/2. Oh, I just did that one. 3/2 times 13/6 equals 39/12. 12 goes into 39, 12, 24, 36. 3 whole times with 3/12 left over. That is not 3 3/4, not that one. 2 1/4 would be 9/4 times 1 2/3 would be 5/3, which would be 45/12, which equals 12, 24, 36, 3 whole times with 9/12 left over. If I simplify that, 3 3/4, they can both be divided by 3. I'm going with letter C. 1 1/8, 9/8 times 3 1/3, 9, 10 thirds equals 90/24. Ooh, 24, 48, 72. Then that would go over. So I'm going to say 3 whole times. That was 72. And then I would have 18/24 left. That can be simplified. Those can both be divided by 6, 3 3/4. Letter D. Oh, I hope those aren't tricking you. Make sure we're simplifying those, even though we don't always have to simplify our own answers. In this case, if we're trying to get to that 3 3/4, we want to make sure that we simplify if we can. 1 1/4 and 2 3/5. Here we go. We have 65/20. 20 goes into 65 3 whole times. 15/20 left over. Those can both be divided by 5. So we get 3 and 15/20 divided by 5 would be 3 and 3/4. Oh, look at that. Also letter E. Okay. Here we go. Almost there. The diagram shows the dimensions of a rectangular wall. What is the area of the wall? We know area, length times width. 6 1/2 times 8 1/2 equals. Let's stick with, I'm going to do the model. So I have 6 1/2. Here's my 6, here's my 1/2. I have 8 1/2. 6 times 8 is 48. 8 times 1/2 would be 8 halves, which would equal a whole 4. 6 times 1/2 would be 6 halves, which would equal a whole 3. 1/2 times 1/2 would equal 1/4. When I add these all up, 48 plus 4 plus 3, 48 plus 4 plus 3 plus 1/4, I'm going to get 48, 52, 55, and 1/4, and we're talking square feet. If I were to use the Columbia C, I'm going to move this down. I've got some space. I can check my answer. Let's do 8 1/2 Columbia C. 2 times 8 is 16, plus 1 is 17 halves, times 2 times 6 is 12, plus 1 is 13 halves. I got the easy one. 2 times 2 is 4. 17 times 13. 5, 7, 1. 1, 2, 221 fourths. So I'm going to do, I need to give us more room on here. 221 divided by 4. 4 goes into 2. No. 4 goes into 22. 5 times. I subtract. I bring down. 4 goes into 21 again. 5 times. I subtract. The remainder is the numerator. The divisor is the denominator. We get a whole 55 and we get 1/4. So my answers match. Yes. All right. Spiral review. Numerical expression. Carson buys 3 bags of pretzels at $2 each. 3 bags at $2. 3 bags of $2. Could we say, there's an expression. Could we say 3 times 2 or 3 times $2? Yeah. 3 bags of pretzels at $2 each. 1 bag, 2 bags, 3 bags. Could I also have done that as my expression? For sure. Either one of those. Jamie takes 1/4 of a yard strips of ribbon and cuts them into pieces that are 1/3 the length. How long are the resulting pieces of ribbon? So 1/4 of a yard. They are 1/3 of that length. 1/3 of 1/4 equals 1/12. And that would be yards. All right. That's it. Questions come to class on the next time we meet. All right. Keep working hard. You're doing great. I'll see you next time.